Okay, in this tutorial we implement Boids. So we head out and implement a Boid class. We wanna, each Boid should be informed by a location, of course, because it's represented somewhere in space. It should have a velocity and it should have an acceleration vector associated. In the constructor of the Boid, the location should be initialized randomly, but somewhere on the canvas. So the x would be random width and the y would be random height. The velocity should be of a small value and into any direction. So for the x value, we say it should be somewhere between minus 2.5 and plus 2.5, whereas for the y value it should be somewhere from minus 2.5 to 2.5 as well. The acceleration on the other hand should just be allocated at this point in time because it's going to be computed at each iteration of the simulation. Finally, we want to implement a short little render method for the Boid. We want to nest the rendering into between the push matrix and the pop matrix command, and between those push and pop matrix commands that basically make this rendering routine independent of any other rendering within our code, we want to translate our displaying method towards the location of the Boid, location x, location y. We want to rotate the Boid by an angle that translates the velocity, or aka its orientation, into an angle. So you have to compute the angle based on the velocity vector, and that's done like this. Finally, we want to draw the triangle that represents our Boid, and we consider a triangle at the origin that points towards the right. So our first point could be the one in the upper left corner, which would be of some minus Boid width, let's say, divided by 2. The y value would be, minus Boid height divided by 2. The y value would be Boid width divided by 2. The point to the right of this triangle would be Boid height divided by 2, and it would lie on the x-axis, so the y would be 0 for that one. Finally, the last point of our triangle would again be minus Boid height for the divided by 2 for the x value, and minus Boid width divided by 2 for the y value. Of course, we haven't defined any of those Boid height and Boid width, so we're gonna do that now. We say those are global constants, so we write down static floats for them. Boid height could be something like 12, whereas static float Boid width could be something like 8. Now at this point in time we have a rendering routine for our Boid and in a constructor routine as well, but nothing else. But that's already sufficient in order to test whether the rendering is done correctly, or at least whether it works at all. So we declare a global array list called Boids, and we look into the setup routine provided by processing. In the setup routine we initialize this array list. we allocate some space for it, and then we create a whole bunch of Boids, let's say 200, and so Boid B equals new Boid, which calls the constructor that was declared above here, and we add this Boid to the Boids array, and that's that. In the draw method of processing, first of all we want to set the background color to something, maybe some zesty spicy lime color like this, which will be some crazy green, and then we iterate through our Boids again. So as long as I smaller than Boid's size, we increase the I, retrieve the Boid B that is at index I inside the Boid's array list, and we render that little dude. Now, one thing that we could also do, we could increase the window size a little bit, because otherwise it would only be 100 by 100. We click on play and we see all the Boids are there, and rotated by some angle. Whether that correlates properly with the corresponding velocities or not remains to be seen. As soon as the Boids are going to be moved, we know whether it's right or not, and that will be done in the second half of this tutorial.